Okay, our next section is solving radical equations. So we're taking chapter 2 and we're putting radicals in it. So we're adding to our PEMDAS and looking at what's going on. So I want to talk about the rules. So we are only going to do rules 1 through 3. We are going to isolate the radical. That means get the radical sign all by itself, just like we would get a variable all by itself. But we want it to be under the radical, and if there's anything outside the radical, it needs to move. After we move what's outside the radical, we need to square both sides, and then we need to that'll undo the radical, and then we need to solve the equation just like we did in chapter 2. Okay, so let's see what that means. So here we go. Number 1, I've got x plus 3 equals -8. So what do we notice? Is the 3 underneath the radical or not? It's not. So the radical itself needs to be by itself, so this 3 needs to leave. What am I going to add to this 3 to make it 0? Well, I'm hoping you said -3 on both sides. So if I add a -3 on here, it's going to be 0. That will help me get my radical by itself. And 8 minus 3 is 5. So then I need to undo my radical symbol. So I put a little 2 here, and that undoes this. It undoes the square and the square root symbol. So now x is all by itself. But remember, if I square one side, I have to square the other. So I'm going to square that 5, and I'm going to get x equals 25. Okay, now let's look at number 2. What's under the radical symbol and what isn't under the radical symbol? So in number 2, this 4 is under there, but the 5 isn't. So the 5 needs to go to the other side. Okay, eventually that 4 is going to go to the other side, but we first have to get rid of the radical symbol. So I need to move my 5 by adding 5 to both sides. That'll give me x minus 4 as my radicand, or underneath that radical. So I'm going to square both sides. That's an 11. That's not a 1.1. That'll cancel. Oops. That'll cancel this, right? So I'm going to end up with x minus 4. 11 squared is 121. Okay. So now I have to solve my equation. I have to get my x by itself. Okay, so I have to add 4 to both sides to do that. And I am going to get 125. Okay, if I wanted to check my answer, like number 1 over here, if I wanted to check my answer, I put my 25 in for my x. 25 plus 3. Square root of 25 plus 3. The square root of 25 is 5. Plus 3 is 8. 8 equals 8. Fantastic. So that's a way to check your answer. Just put it back in the problem. Okay, let's look at this problem. X equals -4. What is something that we've learned in the past? Can we have x equal to any negative number? Nope. So it's fantastic. It's no solution. We don't have to do anything. We could check our answer if we wanted to. If I got rid of the radical symbol, so this is just checking it. If I got rid of the radical symbol and I did -4 squared, I would get 16. Well, the square root of 16 does not equal -4, and so that's why it's no solution, because the square root of 16 is 4, and -4 is -4. So it can't work, and that's your proof why. Okay? All right, let's talk about number 4. So number 4, oh, nope, you don't have to do number 4. Never mind. I'd like you to try 5 and 6. I'd like you to try 5 and 6. They're just like the other problems before. Follow the steps that you do. See if you get x equals 9, and see if you get x equals 173. Last problem to look at is 2x plus 2 times the square root of x plus the square root of x equals 12. How many square roots of x do I have in this pile? I'm hoping you said 2. How many do I have in this pile? I'm hoping you said 1. So 2 plus 1 is 3, correct. So a 3 goes here. Now, is my square root of x by itself? Nope. So I have to divide both sides by 3. Again, that 3 came from adding these two together because they're like terms. This will cancel. So I'm going to get the square root of x is equal to 4. And then I'm going to square this side and square this side, and that's where my 16 comes from. Okay, so make sure that you understand that. And that, my friend, concludes our notes. So have a great day.